Hello everybody! Welcome to Creating the Basic Adaptable Game Engine Library, Part 38, Animation Class Code. In the previous video, we discussed what are the different fields and methods that an animation class will need. Now that we know what we need to write, it's time to actually write that code. And that's what we'll do in this video. So first, we'll go ahead and open up our development environment. And here we are. I'm using IntelliJ again. And we're going to start out by creating a new class. So let's make a new class. This one is called Animation. It's going to handle all our animation-related data. Okay. So first, I need to store a list of textures. And I'll use an array list for that. So public array list of texture objects, and I don't know, I'll call this texture list. Right, and I do need to import the array list class. All right. Next, I need to keep track of how long each frame is going to be displayed. Right, I'll make that a double called frame duration, and the length of time a frame should be displayed. I also need to know if the animation is going to loop or not. Right, so that will be public Boolean loop. So that'll either be true or false. And let's also calculate how much time has passed, or rather store how much time has passed. We'll call that elapsed time. All right. Those are the important fields that we're going to need. If we need something else, I'll figure that out later. For now, I'm going to go ahead and just create two constructors. I'm going to create an empty constructor. This one will be useful if we need to copy or clone animations later on. And in this one, I'll just initialize all these values to basically empty values. Texture list, we'll make that a new array list, storing texture objects. Let's make that not behind me there. See, so we'll store that. Frame duration. Again, this will need to be set by some other program later on. Loop will initialize that to false. And elapsed time will initialize that to 0. All right, much more relevant is going to be the parameterized constructor. So let's say public animation, and what do we need? We need the file name, so the image file name. We also need, let's see, a double for the frame duration, and a Boolean that tells us whether or not this is going to loop. Okay, so first, let's see, I need to load the image file. And so let me go ahead and say image equals a new image and load that file name, or image file name. I need to go ahead and import the image class. And that's from JavaFX. And so there's my image class import. Okay, once I have the image, I need to kind of figure out how large the frames are going to be. And for that information, I need some more data up here. I also need, let's say, int rows and int columns. And so I need this information to determine how we're going to divide up this image file. I won't literally divide it up, but to specify the rectangles that are used to divide it up. So we'll say double, let's call this frame width. This will be the width of the image, so image.getWidth, divided by, well, the width is the horizontal dimensions, and we're going to divide that into columns. So this is divided by columns. All right. Next, we'll need the frame height. So double frame height This will be image.getHeight divided by the number of rows. Right? So for the height of each frame, you've got the height overall, then we partition that into rows. So these are going to be the dimensions of the rectangular regions within each texture. Right, and now we need to create that list of images. So we'll set up a nested for loop here. So for int y equals 0, y less than rows, y plus plus, because we're going to go from the top row to the next row to the next row to the next row, and then within each row we'll work along the columns from left to right. Next is for int x equals 0, x less than columns, x plus plus. Now we need to create a texture. This is one of the reasons I wanted a blank texture constructor, or an empty constructor. And so we do not keep loading in the same image data again and again. Right, so tech.image, right, that image will be the same image we just loaded. And then we have to figure out the region within this image that should be displayed. Right, so let's calculate two numbers. Let's calculate int frame x is equal to x times the frame width. Right, that's the x coordinate of the top left. What is this? Frame width. Why? Oh, because I need an int here. Can I say this is an int? Nope, because get width, I guess, returns a double. That's fine. So I'll just cast this to an int down here. Similarly, we'll say int frame y is equal to y times, let me think about this, the y times the int frame height and so x is how far across we go, so that's going to be a multiple of the width of each frame, and y is how far down we're going to go. That's going to be a multiple of the height of the frame. Excellent. And now I can specify the rectangular region used for the texture. Right, that's going to be a new rectangle. And the parameters here are going to be frame x, frame y, frame width, and frame height. And frame width and frame height are constant and for each frame, but the frame x and the frame y change each time. Once I've created that texture, I'm going to add it to the list of textures. And so this is called texture list. So we'll add that texture. Oh, and we just called it text. Very good. One thing I should be careful about, I also do need to initialize this texture list right here before I start adding things to it. So let's go ahead and do that before we get these things started. Let's say texture list equals a new array list containing texture objects. Very good. Next, we'll also need to store frame duration and loop. That'll be useful information to have. And so after the nested for loop, we'll say this dot frame duration equals frame duration, and this dot loop equals loop. And so these refer to class variables over here. And these refer to the parameters of our function. All right, very good. Now we've loaded an animation. Right, what are the other two methods that we need? We're going to need a method to get the current texture. So maybe we'll write that one next. Right, so this will be public. It will return a texture called getCurrentTexture. And this will depend completely on internal data, like the elapsed time. Which reminds me, in the constructor, we should set the elapsed time. That starts off at 0. So getCurrentTexture, what is that going to return? First, we need to figure out the texture index. So texture index equals, so I'm going to need to do some math here. So I'm going to calculate the floor of elapsed time divided by the frame duration. Right, so what's the calculation happening here? Well, however much time has gone by, right, divide that by the number of frames, and we'll get some kind of a decimal value, but we need to take the floor of that. Right, we need to round it down, and for some reason, even though the result here is an integer, the type is still double, so we need to cast that to an int. This gives us the index of the texture that we're interested in. And then what do we need to do? Well, there could be a problem with bounding. Right, so put this on one line so you can read the whole thing. Okay. What if the texture index somehow gets too large? Right. So for instance, what if elapsed time? Right. What if many minutes go by? Right, and you've run out of frames. We want to avoid an out of bounds error. So we'll also say if texture index is greater than or equal to the texture list size, so texture list dot size, and again we're protecting against an out of bounds error. In that case, texture index, we'll set it equal to texture list dot size minus 1. Right, so this is to avoid out of bounds errors. And finally, we need to return a texture. So we'll return from the texture list, we'll get the texture with that index. Okay? And there's your get current texture. The last thing that we'll need is some way to increment the amount of elapsed time, and we'll do that through an update function. So the final function we're writing is public void update, and this takes in, we'll call this dt, and we'll think of dt as delta time, or the time elapsed since the last frame. So in update, what we'll say is elapsed time plus equals dt. And again, this is the time since the previous iteration. Now, the one reason that we're making this into a function, I guess there's a couple of reasons. What if elapsed time goes past the total amount of time you need to display this animation? Right? What if you're playing an animation and it's 20 frames and you display 10 frames a second? After 2 seconds goes by, you want to repeat and go back to the beginning. So we'll check that with an if condition. If we're set to loop and the elapsed time is greater than the total amount of time we need to display the animation. And so if elapsed time is greater than frame duration times the number of frames is texture list dot size. And so if we're set to loop, and also if that's true, and if both those things are true, then we kind of want to start back over at the beginning. So we'll say, we could say elapsed time is equal to 0, or it'd be slightly more accurate to subtract the total duration. Yeah, that's probably not going to matter too much as we look at this visually. We'll reset elapsed time if we go past this time. All right, there's our update function. That's what we're going to need for the animation class. And in the next video, we'll talk about how to integrate this class into the sprite class, and then we'll actually add an animated sprite into our Starfish Collector game. But that's a good breaking point for this video. Thanks for watching.